In this video, we'll take a look at section 6.7, which is applications involving powers and roots. Now, our first objective here is to take a look at the Pythagorean theorem. Now, Pythagorean theorem works for right triangles only. Okay. A right triangle is a triangle that has a 90-degree angle. So, more specific, that box, this indicates that that angle is 90 degrees. Now, with the Pythagorean theorem, this states that a squared plus b squared is equal to c squared. Now, our side A, this is considered a leg of the triangle. B is also considered a leg. And then the C, the longest side of the triangle, this is called the hypotenuse. So, in other words, the Pythagorean theorem states that one leg raised to the second power plus the other leg raised to the second power has to be equal to the hypotenuse raised to the second power. Now we'll be using this Pythagorean theorem. We could use this to find out a missing side of a triangle. So for example, find the length of the hypotenuse, give the exact answer and the approximation. All right. So in this triangle, we're given both of the legs, and we need to figure out what the hypotenuse is equal to. Okay, well, let's go ahead and use our Pythagorean theorem. So we have a squared plus b squared is equal to c squared. Your c is always your hypotenuse. So let's go ahead and plug in our values. So our a is 5. So we have 5 raised to the second power plus 4 raised to the second power. This has to be equal to c raised to the second power. Well, let's go ahead and simplify. 5 raised to the second power gives me 25, plus 4 raised to the second power gives me 16. 25 plus 16 is equal to c squared. Simplify some more, I get 41 is equal to c squared. Okay. Now, with this equation, my c is not solved for yet. Okay, I still have to solve for c. In order to get c completely by itself, what I have to do is take the square root. Okay, so let me rewrite the equation. So we have c squared is equal to 41. So I just rewrote the c squared on the left side and the 41 on the right side of the equal sign. Now to get the c by itself, we go ahead, take the square root of both sides. The square root and second power, these cancel out with each other. This just leaves me with c. So I have c is equal to the square root of 41. So square root of 41, this is my exact answer. Now to get an approximation, what we have to do is we actually have to put square root of 41 into our calculator. Okay? Since square root of 41 doesn't give us a whole number, it's going to give us a decimal. And that decimal is a number between 6 and 7. But we can't exactly find out what it is unless we use a calculator. So let's do square root of 41. Okay, let's round this to, let's say 3 decimal places. We get 6.403. So 6.403, this is an approximation. This is my approximate solution. Okay. So with the homework, if it asks you for the exact answer, we just put in square root of 41. If it asks you for the approximation, you plug it into your calculator and get the approximation. The reason why this is an approximate answer is because we rounded it. This decimal actually keeps on going on forever and ever and ever. But we can't write out all those decimal places, so we approximate it to 6.403. Let's take a look at another problem. Find the length of the leg. So now we're given one of the legs, the side length is 1. And we're also given that the hypotenuse is the square root of 7. We have to figure out what the length is of the other leg. We have to figure out what b is equal to. Okay, well, let's go ahead. Let's plug it into our formula. We have a squared plus b squared is equal to c squared. So a is given to us. This is one of my legs. So I have 1 raised to the second power plus b raised to the second power is equal to, and now in this problem, I'm given what c is. My c is equal to the square root of 7. Now let's simplify. 1 raised to the second power gives me 1. So I have 1 plus b squared is equal to square root of 7 raised to the second power. Well, square root of the square root and second power cancel out. This just gives me 7. Another way that you could have worked out that problem, so square root of 7 to the second power, this is really square root of 7 times square root of 7. We saw in a previous section where for multiplying radicals, you keep the radical sign the same and you multiply the radicands. So I get square root of 49, which is equal to 7. Well, now we have to solve for b. Let's go ahead and get the b squared by itself first. So I have b squared is equal to 6. And now to get b completely by itself, take the square root of both sides. So square root, second power cancel out. I get b is equal to the square root of 6. So square root of 6, this is our exact answer. To get the approximation, since square root of 6 is not a whole number, we'd have to use a calculator. So if we put it into our calculator, square root of 6 gives us, we get 2.449. So we get b is approximately 2.449. Now let's take a look at one last problem. Application problem now. So we're given a baseball diamond is actually the shape of a square 90 feet on each side. Suppose a catcher fields a bunt along the third baseline 10 feet from home plate. How far is the throw to first base? Okay. Well, let's go ahead, let's create a drawing. So let's create our baseball diamond. Okay, so we have our baseball diamond. Say this is home base. This is first base. Second base. And we have third base. So now we're given that the baseball diamond is actually the shape of a square and it's 90 feet on each side. So each one of these sides is 90 feet. Now it says a catcher fields a bunt along the third baseline 10 feet from home plate. So let's say that the catcher fields the bunt right over here. So this is on the third baseline and it's 10 feet from home plate. So from home plate, this would be 10 feet. Now he's throwing the ball to first. So he's throwing the ball to first base. We want to figure out how far that throw is. But notice what we just created here. We really just created a triangle. Let me go ahead and let me draw this triangle. So we have a right triangle. This side of the triangle is 10 feet. This side is 90 feet. And what we're missing is this last side. That last side is actually the hypotenuse of the triangle. The hypotenuse of the right triangle. So if I want to figure out what that side length is, that's going to give me how far the throw is to first base. So let's go ahead and use the Pythagorean theorem. We have a squared plus b squared is equal to c squared. So I want to figure out the hypotenuse. That's going to tell me how far that throw is to first base. Well, let's plug in our values. My a, I have 10, so raised to the second power, plus, and then I have b, which is 90, raised to the second power, is equal to c raised to the second power. Now with your a and your b, it doesn't matter which one you let one leg be or the other leg be. So for example, I could have let my a be 90, then my b be 10. Either way, you're still going to get the same answer. So let's go ahead and work this out. Okay, so first 10 raised to the second power, this gives us 100. I have plus 90 raised to the second power. Let's see what that gives me. I get 8100. Now I have equal to c raised to the second power. Now I could go ahead and add them. I get c squared is equal to 8,200. So I just rewrote the c so it's on the left side of the equation. So now remember, our c is not solved for yet. You still have to take the square root of both sides. So I get c is equal to square root of 8,200. Okay, so square root and second power cancel out. That gives me the c by itself. Now I could still simplify this radical though. Okay, so let's see what we could take out of our square root symbol. So remember, we could use a factor tree and break it down. Well, first I could break it down with 82 and 100. 82, I could break this down with 2 and 41. And this 100, I could break it down with 10 and 10. Each one of those 10s, I could break it down further if I wanted, but since I already have two of the same number, I don't have to break it down any further than that. So since I have two 10s, what that tells me is I could go ahead and take out one of the 10s and put it on the outside of the radical. So I have 10 times the square root of, and now what was left over is this 2 and 41. So I multiply those back together, I get 82. So I get c is equal to 10 times the square root of 82. So this will give us our exact answer. And now our approximation, because if we're, say you're an announcer, the announcer is not going to say, oh, the catcher threw the ball 10 times the square root of 82 feet. You're never going to hear that in your life. So let's go ahead and get an approximation. There's two ways that we could get this approximation. We could go ahead and put in the square root of 8,200. Okay, we get 90 point, round to 3 decimal places, I get 90.554. We have feet. So that's how far the throw would be when the catcher fields the ball 10 feet away from home plate on the third baseline. Now the other way that you could put into your calculator, you could have put this in as well, 10 times the square root of 82. And you still get the same exact answer. So this was our approximation, which is what you would hear the announcer say. So that was it for section 6.7. As always, if you have any questions, just let me know and I'll help you out.